Welcome to March's Leetcode challenge. Today's problem is average of levels in binary tree. Given a non-empty binary tree, return the average value of the nodes on each level in the form of an array. So we have a binary tree and we want to get the average of each level or height and return it as a list. Okay, so there's really only a couple of approaches here. Either breadth first search or depth first search, right? We need to traverse through our binary tree and figure out what the average is. And that's simply going to be the sum of every node on every height and divided by the total count between them. So here's what I'm going to do. I'm going to create two dictionaries. One for the sum, I'll call it S, and this will be a default dict of, we'll call them floats. And this I'll call T, which is going to be the total number of nodes, and this will just be an int. Now what I'll do is write a helper function for DFS. I will pass in the node, and I need to also keep track of the height. So we'll pass in H, indicating height. So if not node, we return. Otherwise, we're going to go to the left, make sure to add 1 to the height. Same with the right. And really, this part you can put in anywhere you want, but I will put it here, where we're going to say S of height is gonna plus equal node.value, and T height, we're just gonna add 1 here. So let's call this function, we'll call the root and 0 as the height at first. And now we should have everything in here, the total number at every height, as well as the sum. So really, all we have to do finally is to create a list and say for, say I in range of the length of S or T, doesn't matter. What we'll do is calculate the S of I divided by T of I, and we'll append that to our output. Finally, we can just return our output here. And let's see if this looks right. That looks good, so let's submit it. And there we go, accepted. You could probably make this a one-liner if you want. Let's see, what would you do? You'd say something like this. You just return this instead, if you care about that kind of thing. There's also breadth first search solutions as well. The advantage to that is you could figure out ways to use a little bit less space rather than storing all the values here. You could store the sum at that level, at every breadth first search level, and divide it by the total as well. So I do think that saves space. You will need to still create this output. So I don't know how much space it saves, but I always like depth first search, so that's why I'm just gonna stick with this solution. All right, thanks for watching my channel. Remember, do not trust me, I know nothing.